This lesson is why I tape things now. Just makes it easier for you guys to go home and you can actually listen to me and not take notes and whatever. Okay. We have to talk about pressure. I have to define certain things. I have to define the word Pascal. Okay? Pascal is a unit for pressure. Pascal. Okay? I have to, what's wrong?
You're, the only part of you in the frame right now is your arm. You're completely out of the frame right
But
now.
is this on, right? Is this in the frame?
Your hand is out of the frame right now.
How about now?
I think it's still...
I need to see that H.
I don't think it's possible.
Is the H in the frame?
No.
Is the H in the frame? The H is not in the frame. Well done. Okay. So what we'll do is, we'll put the H over here. The H is not in the frame, so we'll make the H right here. Okay? Clear? Okay. Now, we want to talk about Pascal. We want to talk and find out one atmosphere of pressure. STP. And we're going to talk about STP a little bit. STP means standard temperature and pressure. At 0 degrees Celsius, 0 degrees Celsius, right? And 1 atmosphere. That's standard conditions. But what is 1 atmosphere in pascals? Well, that's what we're going to talk about. Now, let's talk about force first of all. I'm going to blow through this. Force is mass times acceleration. Let me first say this about mass. Mass is not weight. Okay? Mass. I feel the weight of this book. It's hard to understand what the mass is. Okay? Weight is a downward force. Correct? This is interesting though. Mass is the same thing as inertia. If I'm in deep space, hundreds of billions of light years from any planetary body, and I'm outside a spaceship, and I have this book in my hand, okay? It's weightless. There's no weight, right? Correct? What's its weight? Goose egg. Correct? What's its mass?
Length times width times height?
No, that's its volume. What's its mass? Its mass is whatever it is. 2 kilograms? I mean, 3 kilograms? Right? Right? That's what the mass is. I am 200 kilograms. 210 kilograms. That's what my mass is. We confuse that with weight, don't we? We do. Right? But this book has a mass. It also has a weight. Like in America, it's easy. We differentiate mass and weight very easily. I weigh 230 pounds, right? It's about 107 kilos-ish, 108 kilos, right? That's my mass. But what are the units? How do we label weight in metric? Newtons, that's right, newtons, okay? That's what we're going to talk about. If I'm in deep space, this is 4 kilos, 3 kilos, let's say, right? Right? So it has no weight. But if I go like this, am I going to feel its weight?
Yes.
If I go like this in space, take your book right now and go like this. You feel that? It's hard, isn't it? Do that 100 times. Your arms will fall off, won't they? Can you feel a downward force? No, you can't. Can you? Not really. If you keep going like this, do you feel a downward force? No. Do you feel a left and right force? Yes, you do, don't you? What would this feel like in deep space? Exactly the same as it feels right now. What's inertia? Inertia is the tendency for an object to remain in motion or at rest unless it's under the influence of an external force.
Oh, so like Newton's first law.
That's it, girl! Force, change direction. Force, change direction. Force, change direction. Force, change direction. Force, 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 force. Right? You got it? Yes? It's weightless, but the mass is still the mass. Clear? Yes? Okay. I weigh 100 kilos. My mass is 100 kilos. What's my weight? Well, can I get rid of this?
Sure.
A is acceleration, G is acceleration due to gravity, M is mass, F is force, FW is weight, P is pressure, and A is area. Are we all right with that? Do we agree on those terms? Okay, good. My weight, mass, times G is 100 kilograms times 10 meters per second squared. What's 10 meters per second squared? That's the acceleration due to gravity on Earth. 9.8, but we round it to 10. It just makes our deliberations a little easier. Okay? Yes? Okay. So my weight equals 1,000 newtons. Understand? Kilograms times meters per second squared is kilogram meters per second squared, otherwise known as newtons. Okay, 1 Newton. Clear? Okay, now, let's take a big box. Right? Right? That box is 1 meter wide, 1 meter deep, and 1 meter tall. Okay? That's going to be, what's the volume of that box?
1 meter.
1. Okay, let's say 1 meter cubed, right? This is 10 decimeters, 10 decimeters, 10 decimeters. What's the volume in decimeters? 1,000 decimeters cubed, or 10 to the third decimeters cubed. What's the volume in cubic centimeters? 10 centimeters, 10 centimeters, 10 centimeters. What's the volume?
Isn't it 100?
Sorry. 100, 100, 100. What's the volume?
1 million.
1 million. Yes! Okay, you with me on that? Yes or no? Okay? The density of water is 1 gram per milliliter. Do you understand that? A milliliter is a cubic centimeter. Right? Easy? All right, yes or no? Okay. How many cubic centimeters are going to go into this box? How many cubic centimeters are going to go into the box? How many cubic centimeters are going to go into the box? It's right on the board. What is it? 1 million. Thank you. 1 million. Right here. 1 million, 10 to the 6th. Right?
Oh.
Right? 1 million. So how many grams are going to go into the box? How many grams are going to go into the box? How many grams are going into the box? 1 million. Because 1 gram per milliliter. In other words, 1 milliliter equals 1 gram. 1 cubic centimeter equals 1 gram. Cubic centimeter, 1 cubic centimeter equals 1 milliliter. Are you following me at all? Hold your horses. You're not going anywhere. Okay? So that's going to be milliliters, cubic centimeters, grams. How many kilograms is that? I'm almost done. I'm almost done. 1,000 kilograms. Right? So 1,000 kilograms goes in that box. Right? The density of water is 1 gram per milliliter, or 1,000 kilograms per cubic meter. If I take water, if I take a box of water, 1 meter high, 1 meter wide, and 1 meter deep, that's 1,000 kilograms. 2,200 pounds. It's 1 metric ton. Do you see why the ocean can destroy a building in a flood? It's unbelievable. If you're stuck under that ling-ling, you're going to get squashed, won't you? Yes or no? Okay. Let me define Pascal. 1 Pascal, PA, equals 1 Newton per cubic meter. Right? Yes or no? That's 1 Pascal of pressure. Pressure is force over area. So on the bottom of that box is how many pascals? $1,000 kilogram per 1 square meter. Why 1 square meter? Well, what's the area of the bottom of the box? 1 square meter, isn't it? So what's the weight? What's 10 times 1,000? Because that's mass.
10,000?
10,000 newtons per what? Per what? Per what? Per what? Per...
Meters cubed.
Right? Now, are you ready? Now, we know that the pressure of one atmosphere equals 760 millimeters of mercury. We're going to do 2 videos on this, but just bear with me. I'm almost done. Yes? You got that? You sure? You sure? Yes?
Why is it meters squared instead of meter?
Because the box is 1 cubic meter, but the area that it sits on is 1 meter by 1 meter. Okay? That's the pressure of 1 atmosphere, 760 millimeters, all right, of mercury. The density of mercury is 13.6 times greater than water. You with me?
Yes.
Yes or no?
The density of mercury is 1.6.
13.6 times greater than the density of water. If the height of the mercury column is 0.76 meters, how tall is water if it were water instead of mercury? Wouldn't it be 13.6 times taller? Wouldn't it be? What's 13.6 times 0.76 meters? Quickly. Approximately what?
10.336.
10 meters approximately, right? Yes or no?
Yes.
Right?
3 meters.
Yes?
Yes.
Yes? Okay, what does that mean? That means that the column for 1 atmosphere, if it were water, would be 10 meters tall. 10 meters tall. Right? So the pressure underneath that bottom box would be 1 atmosphere of pressure, correct? Yes or no? Yes or no?
Yes.
That's 1,000 times 10. That's 10,000 kilograms. 1 box, 1 metric ton. Can you imagine if you were under 10 tons, 10 metric tons of water? Ling Ling, what would happen to you? You'd be squashed like a bug, wouldn't you? It'd be painful, wouldn't you? Wouldn't it?
That's why we wanted to export 5% of the ocean.
Wait, hold it. Now hold it. I'm almost there. Now, how many pascals is that? 10 times that, right? A 100 kilopascals. That's 1 atmosphere in pascals. 1 pascal is, I used to have it somewhere. 1 pascal is 1 Newton per meter squared. 100,000 pascals is 100,000 pascals. But it comes from this concept of force equals mass times acceleration, etc. You get it? The connection between mercury and water, and this, we'll do that. We'll do a second video on Monday. Is it somehow weird? You get it? So somehow it's voluble. Is that a real word? Voluble? Voluble. That's my word. Voluble. Okay? You get it? Now, wait. Let me finish. So would that be heavy? What would that feel like? It would feel like it. This is what it is right now. Do you know? Do you understand that? Right now. Right now. You're under that pressure. Right now, you're under 10 tons of water. Same thing. Isn't that amazing? That's how heavy the atmosphere is. You guys don't look in the slightest bit impressed.
It's not.
Of course you do.
Why are we not squashed?
Because we're used to it.
So, if
We're
we
born
went,
to it.
if we went like super deep down into the ocean, then we would be under 20 tons of water and we would be crushed.
Well, how many meters of water would you go down for 1 more atmosphere of pressure? Where on Earth is there 2 atmospheres of pressure?
The Mariana Trench?
No. You go swimming in the ocean, you go down 30 feet. Go down 10 meters. It's another whole atmosphere. Anybody ever do any scuba diving in here?
No.
Mm-hmm.
You go down 10 meters. It's not far. It's 30 feet. It's not far.
So what if you go down 20 meters?
When do you go down 20 meters?
What if we go down 20 meters?
It'd be 3 atmospheres.
Do we die then?
No, you wouldn't die. No. You wouldn't die. No.
What if we go down?
The human body can take a lot. There are people that go down routinely in construction, 150 feet.
Huh? How many atmospheres would it take to fill us?
That's a good, look it up. Hey, have a great weekend. Start studying for your final. Start studying stoichiometry. Do some problems at the end of the chapter. Do yourself a favor. Email me. Say, I don't need a book to answer questions. Got it? Don't be late for homeroom. Sorry. Bye, guys.